Good morning, children. Today we will learn about vectors, their notation, and then how to add two vectors and also the problem. Now, in vectors we have scalars also. What are scalars? Scalars are the physical quantities which have only magnitude. And then vectors are the physical quantities which have both magnitude and direction. So what are the physical quantities which have only magnitude? Like when you take length, mass, and then the temperature, all these have only magnitude. They don't have any direction. Now, what are the quantities which have both magnitude and direction? Like for example, when you take displacement. In the case of displacement, you say that one particle has traveled from A to B and then it traveled from A to B in this direction. So we say it is displaced from A to B. So AB, this directed line segment, is a vector. So displacement is a vector. And then velocity, acceleration, force also, all these have direction and also magnitude. So these are the physical quantities which have both magnitude and direction. Okay, definition wise, it is like this. Quantities which have both magnitude and directions are vectors, and the physical quantities which have only magnitude are scalars. Now, mathematically, we represent a vector by an ordered triad of real numbers. An ordered triad of real numbers like this. What is an ordered triad? And you have learned about ordered pair. In coordinate geometry, you represent any point by an ordered pair x, y like this. This is x-axis, y-axis. Any point in the coordinate plane, in the two-dimensional coordinate plane is given by an ordered pair x, y. In the same way here, we represent a vector by an ordered triad of real numbers. It will contain three real numbers. This is the first coordinate, second one, and third coordinate. So geometrically, a vector is represented by a directed line segment, and mathematically it is an ordered triad of real numbers. Okay, so now we'll write the definition. A vector is a physical quantity. Vector is a physical quantity which has both magnitude and direction. A physical quantity which has both magnitude and direction. Which has both magnitude and direction. Now, for example, we have displacement. Examples are displacement, then velocity, acceleration, etc. Okay. Now next is scalar. Scalar is a physical quantity. Scalar is a physical quantity which has only magnitude. Scalar is a physical quantity which has only magnitude. It has only magnitude. Okay, now example is just length, mass, temperature, all these are temperature. So these are the scalars. Now a vector, we represent a vector by a directed line segment. A vector is represented by a directed line segment. Is represented by a directed. So that is direction line segment direction is represented by a directed line segment. Is represented by a directed line segment. We also represent mathematically as an order. A vector is an ordered triad of real numbers. Is an ordered A vector is an ordered triad of real numbers. By a directed line segment, and then a vector is an ordered triad of real numbers. So you can denote by a directed line segment like this or by an ordered triad. Okay, we also denote this by a bar. Okay, the notation is like this. You can also represent, we write like this, a, b, we write like this. This is the notation for vector. A denotes the initial point and b denotes the terminal point. So when you are writing AB, it means that the direction is from A to B. The direction is from A to B. We also denote this by small letter A like this, A bar. Always we write bar to denote that it is a vector. Now scalar. Now scalar is just a real number because it is having only magnitude. We write a scalar is just a real number. A scalar is a real number. Scalar is a real number. So this is all about the notation, and then now we learn about different types of vectors. What are the different types of vectors? A null vector or a zero vector. Null types of vectors. Next one is types of vectors. So in this we have first one as zero vector or null vector. Zero vector or null vector. So what is this zero vector or null vector? It is a vector whose magnitude is 0 and there is no specific direction for that vector. Its magnitude is 0 and it can have any direction. Okay, so zero vector is a vector. Zero vector or null vector is a vector which has only whose magnitude is 0. Is a vector whose magnitude is 0. Whose magnitude is 0 and no specific direction. And no specific direction. Okay. Now it is denoted by just a 0 like this. So zero vector is equal to 0, 0, 0 like this. In terms of the notation of A, initial and terminal point coincide. So you can also denote a zero vector like this, AA or PP. Initial terminal points both are same. So this is about zero vector. Okay, next is unit vector. Second type of vector is unit vector. This definition is very important. You must understand this unit vector clearly. Okay, what is unit? Definition wise, it is very simple. Unit vector is a vector whose magnitude is 1. Unit vector is a vector. Unit vector is a vector whose magnitude is 1. Whose length is 1, like that. Whose magnitude is 1. Now, suppose A is a vector like this. Suppose you have a vector A like this. Okay. Now consider a vector whose length is just 1 unit. So this is the unit vector and it is denoted by A cap. Unit vector is in the direction of A is denoted by A cap. Now the unit vector in the direction of A, unit vector in the direction of A is denoted by A cap and it is given by the definition A vector by mod A. Unit vector in the direction of A is A cap is equal to A by mod A. Now you can have a unit vector in the opposite direction of A also. So that is given by minus A. So the unit vector in the opposite direction. The unit vector in the opposite direction of A is minus a cap. So minus a cap is minus a by mod a. The unit vector in the opposite direction of a is minus a cap, that is minus a by mod a. Now unit vectors which are parallel to this vector a are a cap and also minus a cap. So we write the unit vectors, the unit vectors, the unit vectors parallel to a, parallel to the vector a. The unit vectors parallel to the vector a are both a cap and minus a cap, or plus or minus a cap, that is plus or minus a by mod a. Okay, so this is about the unit vectors. Now you have some problems where you have to find the unit vector in the direction of a plus b, in the direction of a plus b plus c, like that, in the opposite direction of a plus b plus c, like that. So in that case it is like this. So the unit vector in the direction of a plus b plus c means what? The unit vector in the direction of a plus b plus c, in the direction of a plus b plus c is a plus b plus c by mod of a plus b plus c. So here we will not write any a plus b plus c whole cap like that. Only for a single vector we write a cap is equal to a by mod a. But definition wise it is same. The unit vector in the direction of a plus b plus c is a plus b plus c by mod of a plus b plus c, like that. So this is all about unit vector. Okay, now we have unit vectors in the direction of positive x-axis, in the direction of negative x-axis, like that. We have standard notation. Suppose that this is x-axis and this is y-axis and this is z-axis, x-axis, y-axis and z-axis. So we are in the three-dimensional coordinate system. Now the unit vector, suppose that this length is 1 unit. So the unit vector in the direction of positive x-axis is denoted by I cap. The unit vector in the positive direction of y-axis is denoted by j cap. The unit vector in the positive direction of z-axis is denoted by k cap. So these are the standard vectors that we use in vector algebra. So I, j, k, I cap, j cap, k cap are the unit vectors. So these are the unit vectors in the positive direction, unit vectors in the positive directions of the coordinate axis, in the positive direction of x-axis, y-axis and z-axis respectively, y-axis and z-axis respectively. So these are the unit vectors along the coordinate axis I, j and so unit vector is a vector whose magnitude is 1. That is the definition. But we'll be finding the unit vectors in the direction of a, in the opposite direction of a, and then unit vectors parallel to the vector a, like that. So this is all about the unit vector. Next is equal vectors. What are equal vectors? Next type of vector is equal vectors. So what are equal vectors? Equal vectors are the vectors which have same direction and same magnitude. Which have same direction. Equal vectors are the vectors which have same magnitude, which have same magnitude and same direction, which have same magnitude and same direction, which have same magnitude and same direction. Okay. Now see, suppose you have a vector which are having the same length and they have the same direction. So these are equal vectors. Now we'll take a parallelogram. Suppose that you have a parallelogram like this. So we know that A, B, C, the opposite sides are equal. So in a parallelogram, AB vector is same as BC vector because they have same length and same direction. And then in the same way, AD is same as BC. AD is equal to BC. So like this, we have equal vectors. So equal vectors will have same magnitude and same direction, and they need not have the same position irrespective of their position, regardless of their same direction, regardless of the positions of their initial point. So then initial point need not be same. So this is about equal vectors. Vectors which have same magnitude and same direction regardless of their positions of the initial point. Their initial point need not be same. Like AD vector and BC vector are two different vectors having different initial point, but they have same length and same direction. In parallelogram, we can see opposite sides are equal, so opposite side vectors are equal, like that. So this is about equal vectors. Now, in terms of ordered triad, suppose you have A1, A2, A3 vector is equal to B1, B2, B3 vector. Then this has to imply and implied by A1 is equal to B1. First coordinates should be same. A1 should be equal to B1, and then A2 should be equal to B2, and A3 should be equal to B3. So only then these two vectors are said to be equal. So two ordered triads are equal if and only if their corresponding coordinates are equal. Is over. Next is collinear vectors. Collinear vectors are the vectors which are parallel to the same line irrespective of their magnitudes and direction. So suppose that you have a vector like this. AB is a vector. You can have a vector, another vector CD like this. Okay, these two are collinear vectors. Now suppose I have a vector PQ like this, and the direction is same as that of ABCD. I can draw a vector equal to this vector here. I can draw a vector PQ here also. So they are collinear. So AB vector, PQ vector, CD vector, they are all collinear vectors. So they can be parallel or they can be in the same line of same straight line. So collinear vectors are the vectors which are in the same straight line or which are in parallel lines. The next is, fifth one is coplanar vectors. Coplanar vectors are the vectors which lie in the same plane. Coplanar vectors are the vectors which lie in the same plane, or in parallel planes. Which lie in the same plane or in parallel planes. Even if they lie in the parallel planes, they are considered as coplanar vectors. Now suppose that there are 4 points in a plane. A, B, C, D are 4 points. Now they can be proved as coplanar if the vectors AB, AC, AD are coplanar. So we'll use this concept in solving the problems. The 4 points are coplanar if the 3 vectors AB, AC, AD are coplanar. So this is about the coplanar vectors. Next is multiplication of a vector by a scalar. Multiplication of a vector by a scalar. Multiplication of a vector by a scalar. So how to multiply a vector by a scalar? Now suppose that I have a vector A as A1, A2, A3. So this vector can also be written as A1i plus A2j plus A3k. In terms of ijk, you can write this vector as A1i plus A2j plus A3k. Now suppose I have to multiply this by some number. Suppose it is some 3a. So 3a vector means I should multiply each element by 3. I should multiply each element by 3. That means it is 3a1, 3a2, 3a3. In terms of ijk, it will be 3a1i plus 3a2j plus 3a3k. So like this, we multiply a vector by a scalar. Scalar is a real number for us. Okay, next is negative of a vector. What is the negative of a vector? What is the negative of a vector? Suppose that A is a vector. So let A be a vector. Then the negative of a vector is a vector. The negative of the vector A is, so the negative of a vector A is a vector whose magnitude is same as that of A, is a vector whose magnitude is same as that of A, whose magnitude is same as that of A but have opposite direction of A. But have opposite direction of A. So it is denoted by minus A. It is denoted by minus A. So the negative of a vector A, the negative of a vector A is a vector whose magnitude is same as that of A but have opposite direction of A. So it is denoted by minus A. So magnitude of a vector is denoted by mod A. This is the symbol. So mod A is same as mod of minus A, but the direction is opposite. So this is about the negative of a vector. Now suppose you have in terms of ordered triad A1, A2, A3. Then minus A vector is like minus 1 into A, no? So multiply all the elements by minus sign. Minus A1, minus A2, minus A3. So like this we write the negative of a vector. Next is we'll learn one condition for two vectors to be collinear. Suppose that A and B are collinear vectors. Next point, suppose that A and B are two. Suppose that A and B are two collinear vectors. Suppose A and B are two collinear vectors. Then you can write A vector as some constant times B vector, where P is a real number. You can write one vector as constant times the other vector. So suppose that A is A1, A2, A3, A1, A2, A3, and then B is B1, B2, B3. Then A is equal to TB means it is like this. So this is TB1, TB2, TB. So these two should be equal, no? So A1, A2, A3 should be equal to TB1, TB. Now equate the corresponding coordinates. Then A1 is equal to TB1, A2 is equal to TB2, and then A3 is equal to TB. Now this will imply A1 by B1 is T. In the same way, A2 by B2 is also T. And A3 by B3 is also T. So A1 by B1 is equal to A2 by B2 is equal to A3 by B3 is equal to T. So that T you can write T, no problem. So to prove that the vectors A and B are collinear, we use this concept. So the corresponding coordinates should be proportional. So the ratio same undali. A1 by B1 is equal to A2 by B2 is equal to A3 by B3. ఈ ratio same వచ్చిందంటే అది collinear అని చెప్పేస్తాం. So that that constant is be taken as P. So this is one point that we use in solving the problems. Okay, next is position vector of a point P. Next topic is position vector of a point P. So position vector of a point P is the vector OP. Is the vector OP, where O is the origin. Where O is the origin. Where O is the origin. So suppose that position vector of a point P, that is the definition. So suppose that you have the coordinate plane like this. P is a point. So O is the origin. OP vector is called as the position vector of the point P. So we write OP, suppose OP is equal to A. Then we also write P is equal to A. This is the notation. P is equal to A. Now suppose that OP is equal to A is equal to some 1, 2, 3, 1, 2, minus 5. This is the point. So you write P point as 1, 2, minus 5 like this. Or you can also write it as I plus 2j minus 5k like this. So this notation is very important. Should understand properly. So position vector of a point P means it is the vector OP. OP is, we also write OP or just P and then write the coordinates. You can write that in terms of ijk also like this. And then mod of OP, the length of OP is root of 1 square plus 2 square plus minus 5 whole square. The length is given by this formula. Like suppose that P is equal to or OP is equal to xyz. So that means it is xi plus yj plus z. Then mod OP, the length of OP is root of x square plus y square plus z square. So it is the square root of I coefficient, square of I coefficient plus square of j coefficient plus square of k coefficient. So this is about the position vector of a point P. So next is triangle law of vectors. Law of vectors. What is this triangle law of vectors? Suppose that AB is a vector and then BC is another vector, then it is equal to AC. So suppose that you have two vectors. Suppose that you have two vectors which represents the sides of a triangle, AB and then BC. So AB plus BC is equal to AC. So this is AC. Suppose AB is equal to A, BC is equal to B, then AB plus BC is equal to A plus B. So this is the triangle law of vectors. The sum of two vectors, A and B is if they represents the adjacent sides of a triangle, then the other side, it is from A to C, then the other side represents the resultant of these two vectors. So this is called as a triangle of vectors. Now see, you have AB plus BC is equal to AC. AC can also be written as minus CA. When you interchange the initial and terminal point, that means the direction is changed. So you will write negative of the vector. AC is minus CA. You are changing the direction, so you must change the sign. You have seen in the negative of a vector, AB is a vector, then AB is equal to minus BA. When you change the direction, it becomes minus BA. So if you write like this, then it means that AB plus BC plus minus CA is equal to 0. Minus CA can be written as, when minus CA comes this side, it is plus. So AB plus BC plus CA is equal to 0. So this is the addition, triangle law of vectors, triangle law of addition of vectors. It is the triangle law of addition of vectors.
మేము ఇంట్లో గుడ్లు పెట్టకుండా మమ్మల్ని ఎవరు ఆపలేరు. నేను ఆపగలను. నీకు తెలీదా మేము ఏడీస్ దోమలమని? మేము డెంగ్యూ చికెన్ గుని అని వ్యాపింపజేస్తాం. మాస్టర్ గారు స్కూల్లో డెంగ్యూ నుండి నివారణ కోసం అన్ని వివరాలు చెప్పారు. అవునా బాబు, మాకే ఛాలెంజా? గుడ్డు తప్పకుండా పెట్టి తీరుతాను. పెట్టనివ్వను. అయ్యో, ఇక్కడంతా శుభ్రంగా ఉంది.
డెంగ్యూ నుండి నివారణ కోసం కూలర్ లోని నీళ్లను ప్రతి వారం మార్చండి. బకెట్ ఇంకా ట్యాంకులని చాలా జాగ్రత్తగా మూసిపెట్టండి. మొత్తం శరీరం నిండా బట్టలు వేసుకోండి.